Good afternoon, everyone. So today I would like to continue our discussion on chapter 2. Okay. So basically, the idea of today's class would be more or less on the discussion on the reasoning, whereby I think I already briefed you all guys about the inductive and deductive last week. So whereby a short discussion yesterday was like last week A is B, while B is C, and we can say that finally A is as a conclusion, right? So this one is, we call it premises. So that is the idea of deductive, while inductive is the idea, this one and that one. Okay. Meaning in other words, that is a general, specific, general. So while this one is specific, and general idea. So that will be the contradict of deductive and inductive. Okay, let me introduce about the content for this particular lecture session. I think I will start on the revision itself. So revision means I think in last particular class I do have give a simple particular kind of quiz. I think we will take a look at that. Kind of tiny questions, and we discuss later. So then I would like to introduce to the AI techniques, whereby this one regards to the several techniques we have currently. So we have introduction, we have induction. Okay. This afterwards we will compare them between the two. Okay. So then we will take a look at the logic reasoning, whereby the premises is the one that I said just now, is this one. Premises is statement, statement. Okay. And lastly, I will be showing you guys the scenario number 1 and number 2, and including the exercise, and will be the final notes for today. Okay. Okay, based on our discussion last Thursday, basically I did give to you guys about this activity number 2. So language translation device is in activity number 2, you need to decide either AI or non-AI. So which one is which, right? If you can remember about that. Sorry. Okay, so the language translation devices, I think majority of us is agreed about the language translation device is done by AI recently. Okay, so whereby we can say that we have what we have lately, GPT, we have DeepSeek, we have many more. So, but the thing is not AI. It's AI translate directly. It depends on the searching algorithm, whereby it comes from the database. Okay, it's not smartly done by AI, but it's just like processing. Okay, so this is not AI. I think the early age of the translation period. Okay, so the second activities for that particular quizzes is adding a number. Adding a number is simple. So let's say we teach the students to add 2 plus 3, for example, that would be 5, and 5 plus 5 will be 10, so etc. etc. So the idea is to say that so example 1, 2, 8, and 2, 4, 8. So the 2 is basically this plus this and etc. So this is what we call it in binary summation. Okay, So it depends on how it goes. So basically, the additional two numbers is basically not AI. For the general perspective, it's not, but it more or less for the logic. We can count on Boolean. We can count on additional, subtract, multiple, or division, whatnot. So we might also have many logics behind the logical perspective of in maths. Okay. Differentiation between cat and dogs. For example, in this particular sense, we might consider the cats and dog in perspective of an image. Okay, image. Because say that we try to discriminate the cat and dog in natural language processing, so whereby we can say that this is this, and that is that. So this is the comparison between linguistic spelling. So, but the thing is, if we wanted to discriminate the two things, two objects within the meaning of that particular images, so whereby it's not belonging to NLP anymore, but it belongs to what they call it, computer vision task, whereby we say here as classification. Oops, sorry. Belajar. Okay. Where is it? Okay, classification. Mm, Okay, so that is the idea of understanding or classifying the image one to one for two classes cases. So we might also say that this differentiation cases, human separating with experience is not AI. But the thing is, when we talk about AI, so use this based on the feature in those images via CNN. So whereby, let's say we have this one. This one is first layer. This one is second layer. This one is third layer, for example. So we bring along the cat, or how we sketch a cat. So this is cat. Okay, so we bring this particular image in the CNN. So basically that in example, so this particular thing will be connected to this and that and that and that and that. So finally they will decide to us as cat or dog in numerical sense. So whereby we need to have the activation function over here. So I think this will be detailed by Dr. Hidayah, I think, afterwards. So this is the how AI, okay, based on the feature, sorry, I need to change my color. Okay, based on the feature by the given image. So this is the image, let's say this is cat, without knowing that that is a cat image. So we just push the image inside the neural network. So this one is named as layer. This one is also layer. This one is also layer. So input, hidden, and output layer. So whereby at the end of the day, this particular output will be detecting those image has been insert for this particular network to be as 0.1 or 0.75 kind of things. So 0.1 is dedicated as a cat, for example, and 0.75 is dedicated for the dog. So whereby we can say that we have sigmoid over there. So threshold has been considered in this sense. So that is AI. Okay. Right. So I think more or less it's clear about this. So languages is AI or could be not AI. Adding a number is not AI, and then differentiating cat and dogs is AI. Okay. So I think it's not talking about cat and dog even. So we might also say that separating the cat this say the example, this is a cat. We segmentize them, and this area is background, so this one is foreground. So that is not classification, but that is segmentation. Okay, perspective, whereby there will be one more perspective to be looked at. Yang student IDP saya buat. So if we take a look at this, bounding box, they call it, BOUN. So bounding box is basically the one that we fix in training session. So let's say this is me, human. So we press the square, which the particular dedicated object is laying down. Okay, maksudnya in this particular box, green shaded area, so the cat is there. So example, when human is here, so shading box is approximately be like, sorry, be like this, exactly on the top, and then followed by this. So perasan tak, if you take a look at the YOLO, so they do have like 0.95 and so on and so forth. So this is not classification and even segmentation, but this is detection. Okay, so ilmu lain. Okay, alright. So we have several tasks in computer vision. If we may discuss over here. Okay, right. So introduced to AI techniques. So there will be vast or huge technique to be done or to be discussed in AI particularly. So whereby toolbox of, okay, so when we talk about toolbox, so that would be the analogy for saying that AI containing huge of the techniques, a vast of techniques. So we have, but the thing is, the things that been discussed in AI is basically depend on the problems. So this would be the keyword here, guys. The moment that you understand the problem, for instance, you may portray the solution using AI. So for instance, the problem that we have in hands, detecting human temp passing entrance at KLIA immigration. So for example, so this is the problem that we have in hands in our mind. So the idea is there will be several tasks be done by AI. So one thing is you might using the image thermal. So we might using the detection for the instance, and then we see, and we might see the facial idea. So because yesterday I saw in one of the AI expert tracking the temperature of the body by looking up the face style. So let's say that the face is like this. Ini 37. Contoh demam, dia masam. So that would be the idea. So based on this particular problem, even though the problem is the same, but the solution is might be different. So several. So we might use the classification, we might use segmentation, or we might use the face recognition, right? So there will be various. So this is the main thing in AI. You need to digest the real problem which we face. Okay. So from the rule-based system to the machine learning and deep learning. So basically the rule-based learning is example, if A, then B. So this is the traditional or conventional idea that has been discussed widely in AI since 1950. And machine learning comes in 80s or 90s, and deep learning coming in 2000. So widely used. Okay? Each approach has its strength and weakness, making it essential to choose the right technique based on the problem domain. So that's the reason why I mentioned you earlier about this. First, you need to know well about the problem. And second thing, you need to list down what is the possibility of the problem could be solved by AI technique. And then followed by the domain itself. For example, Image thermal is surveillance, detection is the security, and facial is the subjective preference of identification. So that might be a different angle to be seen. Okay, and obviously data availability. Okay, this is the most important in AI. Okay, so obviously this will be the second. So when we talk about AI, many times. So the first is this, and the second is this. First, you need to have the data. Example, when you talk about the detection human temperature, so you need to have 1,000 or even million data for people are coming into the immigration gate. So that would be the easy in order to compute or to make the solution for image thermal. Okay. Computation resources. Ini menarik. Do you have GPU? Do you have CPU? And do you have anything? So that would be the resources that in our hands. So for example, speaking of the GPU, you might run through the Google Colabs and paper on something. So speaking of the CPU and GPU, you might have your own dedicated machine in your room. So that would be the crucial thing for AI, right? So there will be several techniques in AI. So basically, we could have what they call it rule-based system. Okay, then we might have reasoning. Okay, so we might have learning. We might have what to say, deep learning. So we also might have what is the thing that happened right now? Um, large language model. Okay, so this is the time base for the AI technique so far, I think, from the beginning. So we have rule base. In this particular rule base, we have many things to be understood and to be digested with. So okay. Okay. So for example, oh, how to undo it? So previously, okay. No. Oh, tak apalah. Oh, sekejap. Where's my slide? Okay, it's good. It was blank then. I need to share, I think. Salah tekan. Okay, right. So the idea of doing this is when we talk about, okay, this one is rule based, okay, and then this one is reasoning. This one is learning. This one is DL. Okay, it could be a neural network and LLM. Okay, so rule based, what we have over here is we have constraint, we have rule based, we have tree, we have what else? We have if then rules. So reasoning, we have induction, inductive, and deductive. Okay. Learning, we have many. Learning, we have regression. We have SVM. What else? We have PCA. What else? We have random forest and so on. Okay, deep learning. What we have? ANN, neural network, and so on. So we have LSTM, we have RCNN, we have many more. Mass RCNN. So LLM, we have many. So this is the thing that we need to be know well about. Where are we during the time that we talk about AI? So eventually, if I portray the AI for me, so basically for me, I think this would be beneficial to research level because I think 2027 and above. So this would be, so nowadays also too, but people are trying to understand the LLM basis, but yeah. And recently, I think 2020 and 2027 will be okay with learning DL and NN. So I think from 2027, we should move to another angle of stairs. So I think this one is done, 2000 to 2020. Okay. If you are still, so it might be said that SVM, PCA, and RF is not relevant nowadays, but still relevant. But we need to, how to say, add on and size up the application of that particular, let's say you have FYP project. So you are dealing still with support vector machine. So support vector machine is very conventional in this day, not in those days. So, but I think my suggestion is to kacuk, to combine the things with conventional one with the recent one to make things become brighter and fresh, the idea. So, yes, I think. But it depends on perspective how we see the technology. Okay, right. So, introduction of to AI also, I think more or less we will talk about this. Am I too fast for you guys or okay? Can anyone respond? Okay. Okay, okay, thank you. Terima kasih. Okay, so speaking about the technique, so we have tons of technique in AI. So people are doing describe and match pun AI, constraint satisfaction is also AI, tree searching also AI. So tree searching, guys, is very widely used, mainly in algorithm searching. I think from 2000 to 2020, memang banyak. So it's not saying that only the tree. So the tree is basically, if we portray the tree, so basically we have pokok, dahan, and so on. So whereby in Chinese they call it this. And yeah, so obviously we can have this one, tree. So whereby we have node, NODE. So from the top to the bottom. So the moment that we spoke about the tree, so basically we need to consider either we start to the top to the bottom or top to the right and left. Okay, so later on we discuss about that. A rule-based system, I think I did mention earlier about if then. Okay, if A then B, so kind of. Okay, and then time goes by, so the things has been changed to machine learning model. So I think more or less, you guys in Berg or even Burr know about this. So machine learning is the earlier things than deep learning. So step by step evolution. But the thing is, oh, okay, fuzzy is I think before this, but yeah, along this way, fuzzy. So NLP is coming nowadays. Okay? So based on the technology, machine learning, I think learn the data and making them adaptable and can be estimated. So example, we have a graph. Contoh okay. A student attend the class 1 time, 2 time, 3 time, 4 time. So student who attend class 1 time getting D, for example. This is E. Sorry, this is C. This is B. This is A. So student come to the class for 1 time getting D, for example. C, B, and A. So let's say that particular student attend the class for 3 hours, 0.5. So that would be here, right? So because when we talk about machine learning, the idea of machine learning is try to portray the trend of that data. So example, so this is the data. So we try to put one particular trend data from that particular data 4 points. So yang ni anggaran untuk trend. So then future, say that we have a new data comes in. Whatever. Okay. So new data. So yang ni data lama. New data is, let's say 3.25 hours. So this is 2.5 hours. Okay, tarik. Okay. Student yang datang 3.2 hours, 2.5 hours should be A minus, for example. So this is the estimation based on machine learning model. So model ni dikenali sebagai this. Right. Okay. Okay, then we have another things like let's say segment linear regression. We have logistic regression, and so on and so forth. So we don't, and then we have deep learning. So deep learning unstructured data but require massive. Okay, the data is being unstructured but require a massive. So this one is the keyword. So say that you are playing with this. So example, to discriminate cat and dogs. So are that enough to have 150 images for cat and 150 images for dog at the same time to get a good model to discriminate cat and dog? So the answer is no. So because the keyword here is massive, right? And then goes again to let's say detection also too, because the moment that we wanted to make the boundary box along my body, so basically we need to have many images. So say that you have 100 images, that would be fine for a good lighting and a clean image and the clear room. But say that saya tutup lampu then dark, so it's difficult to see me, right? So that is the idea of massive data with the unstructured data, based on the unstructured data. Okay, evolutionary algorithm offer an optimization strategy from fuzzy logic helps the vague and uncertain scenario. Okay, the fuzzy means the idea of came down, I think, along the way of machine learning, right? We can say. So what is vague over here? I think I did discuss here last Thursday. So example, tall and short. So we have very tall, quite tall, tall, short, too short, kind of. So based on the two definition, tall is one, zero is short. But in fuzzy, we could make the ambiguitiness of or uncertain scenario like quite tall is 0.75 instead of in the conventional one and zero saja. So very tall is 1, tall is 0.5, short is 0.4, and too short is 0.25. For example, so now we have 5 particular uh, value to reflect to the what we are discussing right now. Instead of tall and short, 0 and 1. NLP, Natural Language Processing, bridge the gap between human and machine. I think I did mention to you guys last week. So imagine that this is cell phone. So basically we try to say something, ChatGPT, tell me the menu for iftar for today. So then it will process, okay, the menu for today is murtabak ayam, for example. So that is the natural language processing, means human talk with the robot, machine understand, and machine respond immediately in real time to the human. Okay, so that is NLP. Okay, so let we jump something deeper inside this for a while. Okay, describe and match. So describe and match is basically simple, but I think it's very crucial in this particular sense. So we have describe and match. Swai, padan. In Malay, we call it padan. Swai. So this one, describe. So I think you know that the meaning. Okay, so this is what we call it, tower, Hanoi Tower, Tower of Hanoi. So basically, it's a classical problem used to illustrate the recursive algorithm and problem-solving strategy in AI, particularly describe and match. So this one is this particular technique, right? So the idea is we have 3 pillars in a row. So basically, when we talk about AI strategies, the problem here is how to put the A, is it pack? Okay, B pack and C pack. So how to relocate it, the red, green, and blue disk to be here without putting the blue on the top of green or on the red. So yang besar tak boleh duduk atas. The larger cannot be on the top of the smaller one. So that will be the requirement in describe and match. So that is the idea. But the thing is the B pack could be used as an intermediate pit stop, or what we can call it as auxiliary. Okay. Later on we discuss about that. Okay, this is the idea. You are given the three rods. Let's call them A, B, and C. Set of discs of different size. The discs are initially stacked on the rod A. Okay, they call it rod A over here. Decrease or the size with the largest disc on the bottom and small on the top. The objective is to move all the discs from A. This is A. This is B to this C. Okay, A to C. This one. But following the rule. So number 1 rule, number 2 rule, number 3 rule. So the first one, you should obey only one disc can move at a time. So meaning to say, example, this could be moved to here in single time. So let's say this is right. Dia tak boleh pergi dua-dua sekali. Okay. And number 2 is a disc can only be placed on the top of the larger or empty rod. Okay. So meaning the red can be located at two places. One is empty rod, or the other one is red should be on the top of green or blue. So that will be the second requirement. So while 3, you must be rod B as auxiliary to hold the disc temporary. So B ni boleh guna untuk pit stop sementara, untuk charge. Okay. Right. So the idea of this describe and match solution is this. We wanted to pull all the rods from the B and C. So finally A from A to C. So basically the C is completed when we push the middle of this rod and this disc to be in the third rod. Okay. So this is the idea. Okay. How can we make it? So there will be several ideas of to move the smallest, the second and the big one, small, medium, and large. So basically, it depends on the idea of how you put it, based on the requirement given. Example, a disc can only be placed on the top of the larger. Contoh, if we move this disc to be here, okay, let's say here, the second step must be yang ni dia tak boleh pergi sini. Sebab the larger cannot be on the top of the smaller, kan? So the choice that we have for the median is to be here. Okay, faham? Okay, the second rule. So then, then what happened to the third? Okay, now, the rule number 1, so B and C tu cannot be moved at one time simultaneously. So meaning one by one, right? So that is the rules of what we are doing, are given by us in this particular describe image. So then we have the idea of solution of what we have over here. Solution ni ada lah, don't worry. So we have this, the first step is we bring this one into here. So this one is one step. Kita gerak satu ni, it's not two. Okay, ni di sini. So then this one is going to be here. Second step. Jadilah ni. Okay. So then, the third step is bringing back this. Because the smaller can be top of the larger, kan? One. Okay, jadilah ni. So then, how to make things happen? So because the 3 ni, so the most bottom need to be the largest one, kan? So kita kena bawa juga this one to be here. So langkah 3, langkah 4. So then we go there. So remember, atas 3 ni should be the middle yang ni, kan? Macam mana nak bawa dia? Kita kena pantulkan ni for sementara, duduklah sini dia. So then kita patah balik dia ke sini. And finally we have this. So 5, 6 and 7 step. So we do have 7 step to go. Okay. So the idea of 7 step mean from the max 2 to the power of n minus 1. So the moment that we have 3 discs, okay, n equal 3, so mean 2 power of 3 minus 1. So means 8 minus 1, 7. So the moment that we have 2, so 2 to the power of 2 minus 1 mean 4 minus 1 is 3. So kalau kita ada dua example, if we do have 3 pillar, so we have 2 discs. So the step taken will be 3 langkah. So if we have 3 discs, that will be 7 step. Kalau ada 4 this, berapa tuan-tuan dan puan-puan? 2 to the power 4 tolak 1. Sorry. Sama dengan 15 step. Tak. Okay. Ada check. Sekejap. Saya tak perasan. Okay, alright. 15. Okay, right. 15. Sorry. Saya tak tengok ni. Sambil-sambil tu saya perlu buka chat juga. Thank you for Hakimi. Alright. So that is described in mesh solution. I think this will be the one. Okay, the true one is this. 1, 2, 3, 4, 5, 6, and 7. So this is the step. But remember that what we have right now is it blue? Blue will be fine, right? Okay. So the idea of going to the left on the right. So I mean, based on the rule number 1 or 2, only one disk can move at a time. So meaning for this, let's say any. Okay, so the choices that we have right now is to move the top upper disk to 2 places kan? 1 place, 2 place. Tapi kita kena buat satu-satu one by one. So that is, we have this and we have this. Okay, ada two ways. So from there, so we have we only have one choice because of okay, why we have one choice here? Kita tak ada yang ni guys. Siapa boleh jawab? Then why we don't have this guys? Biru ni. Sebab ini ada dua. Anyone can help me? So constraint satisfaction technique is the idea of when we talk about different things compared to describe and match. Constraint is, what is constraint in Malay, and what is constraint satisfaction in Malay, and technique kepuasan kekangan. Is it true? Okay. Each state of the system is represented by a set of value. So I think more or less for this particular thing, jap ada chat. Aidil Hafiz. Okay. In the CSP, basically we have states over here. We have variable, and each variable we have value. Okay. So make sure that in order to understand the constraint satisfaction is we need to know the states, variable and value. So the state is represent, meaning the state, variable, and the variable ni respond by the value. So dia berantai. So solution of the problem is found when every variable, so every, okay, is assigned if a value is satisfied with the constraint. Okay, every variable assigned with the value agree with the constraint. Constraint meaning syarat ataupun kekangan yang dibuat in that particular sense. Defined as a logic. Okay, so definition is logical relation among the variable. Example, a circle is inside a square. For example, okay, a circle is inside a square. So this is circle, this is square. Express a constraint between two objects without specifying their exact position. So meaning to say that if we draw or sketch a circle over here, so we can say the circle should be here and the circle also should be here, as long as inside the range of the square, right? So then we can say that this is satisfy the constraint that we have, right? So that what we call it constraint satisfaction technique. Okay, for example, say that I have a circle over here. Is it the same? And when I move the circle over there, and again, I put it here, and I put it there. So same, right? So meaning to say that as long as the circle is inside the square, there's still a good satisfaction or constraint satisfaction still approved. Okay. So right. So a constraint satisfaction problem consists of two components, as I mentioned earlier, about this state, variable, and value. Okay. So variable, and this is domain of state, and this the value. Oh, sorry. So this is T, guys. So C is the constraint that we could bear with or discuss with. Okay, a state is assignment of the value. Okay, a state assignment of value to a small sum or all the variables. So meaning variable two is probably can be utilized or might be not utilized. Okay, consistent assignment does not violate the constraint as long as this ball is not moving to the outside, so this still approved by the constraint. Okay, kalau ni ng. Okay, so that is the idea. Assignment is complete when every variable is mentioned. So say that we have several variable in those discussions. Say that we have 4. So the 4 is mentioned and approved in that particular constraint. So a complete assignment that satisfies a constraint. So the CSP is a complete assignment when satisfied all the constraint. So for example, so we have variable as Western Australia, and we have Northern Territory, and we have Queensland, North South Wales, Victoria, and etc. So the domain is red, green, and blue. So domain is presentation or wakilan. Okay. So constraint meaning adjacent region must have different color. Example. This and this should be different. Let's say this is red, should be blue. So then this and this should be different color. This is red, this is green. So then this is green and blue. So then okay. So while green here, so what will be here and here and here? So you need connected. So then we need to think about the colors. Okay. So then we can see over here. The solution are complete and consist as based on discussion. Complete and consistent, does not violate, and satisfy all constraint. Okay. WA in red, northern in green, southern in blue, and etc. So basically, sorry. Ini tak boleh merah. Okay. Western and northern is not the same color. Western and southern is not the same color. This one is not the same. This one too is not the same. Well, this one too is not the same. This one too is not the same. This two is not the same. This two is not the same. Well, this one is not the same. So then, complete and consistent assignment has been given by the map of Australia by dividing the states, right? So that is the one. Okay. So okay, back to the tree. Okay, tree. Are we good so far? 40 minit. Okay, so far so good. 20 minit. Okay. Okay. So I think the next one represent. Now we are at 3. Okay. Oh, tak sampai separuh lagi. I'm going to half lah. Okay, dah tu sejam. Okay. Tree searching. Tree searching is fundamental concept in AI and computer science. So I think more or less we can always say it's not truly, but so AI here and computer science and we can call it computer vision is a partial of the AI and computer science, basically used for solving problem that can be represented by a tree structure. So tree structure, we can see the tree. We have the top of the tree. We have a kind of pyramid style patenting, and we have roots over here. So meaning to say that the idea of bringing the data from the top to the bottom, right? So that is the tree itself, the definition. So whereby in the data science, what we call the dahan kepada dahan, kalau in Japanese they call it eda. Saya tak ingat kanji ni. Okay, so this to be here is connected by the edge. rantaian tu, the chain. So until the ground of the tree, it become wider and wider, right? So this one is the parent, this one is the child for A, and then they become parent for a while again, and this is the number 2 child. So that is the one, right? So means we can discriminate or describe each of the particular parents could be having a child, while the next generation child is having again child. Okay, so that is the thing known as node. Okay, so it involves systematically exploring nodes. Okay, what we call it state in a tree to find the solution. So basically, siapa tadi? Hakimi cakap sebab dia nak path paling cepat. So yes, the answer is yes. Saya sengaja tak jawab kat situ sebenarnya. So try to find the fastest path, or we call them shortest path. Okay, meaning 1/2, 1/3, for example. Macam tadi tu yang apa? Tower of Hanoi. Okay, things. So, but this is the way different thing. 3. Okay, in tree searching, guys, we have 2 things. 2. One is depth. Depth. The one is breadth. Dia adalah dalam, lebar. Depth first searching. Breadth first searching. Pencarian kedalaman dahulu, pencarian kelebaran dahulu. So that would be the direct translation lah. Saya pun tak pasti dia punya translation betul. Then we can say when the top of the tree is described by the A node. So for example, this would be parent, the parent of the parent. So godfather. So meaning A have 2 child. Okay, so A and B. So the idea of the one that we can see over here is how the depth first searching is going to be. They will be start from the top and go to the bottom. Okay, and somehow at the bottom child. So they will be going left to the right. Perasan tak ni? So imagine that this is a group. Okay, this is top. So this is in here. Okay. So imagine B is the top. Okay, so B has 2 kids, 2 child, D and E. So basically for death, the moment that A is having B as a kid first, dia pergi sini dulu. So B is a parent right now, is going to be having 2 kids. So the path of the data will going to be the bottom and left first, and going upstairs back and go to the right. So maksudnya, kamu tengok anak panah saya, 1, 2, balik-balik, pergi balik. So that is the one. After reaching the E, so basically we the E now becoming the next parent. Okay, so E got 2 kids. So then go to H. H ada 3 kids. So dia pergi dah satu, patah balik 2, going back 3, patah balik 4, going back this, and going back that. Okay, if we want to complete all the thing, kamu tengok ni dash pergi sini, then goes here, go back, go down, go back, go back, go back, go back. Dah pergi sini balik. This, 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 this. Ni final. So that is the depth first. Okay. So they'll be going top to the bottom, and when reach the child, they will be covering all the child which the parent has. Okay. Kalau tak, sehari tu dia tak settle. Dia akan go around and try to find the available child. Comparingly to the breadth, when we talk about layer by layer, so say that this is the first, second, third. So meanwhile, we can say that this thing is going like this first, dia begini second, rentas, cross section. This and that. This and that. Okay. So, but here, say that you are given a questions over here. So say that we want to try to find N and J. Okay. Which one is met first by the depth first searching, and which one has been met first by breadth first searching? Can you do it by 5 minutes or 7 minutes from now? Which one of the searching strategy is reached to the N and J at first? Then you can compare. For example, here, straight to the point, the answer would be like this. The moment that we search by depth first searching, the N and J, which one come first? So I did show you this and this, right? Go here. So N would be first, and followed by J, kan? So, but the moment that we choose breadth, so basically J is first, not N. So that would be different thing, right? So based on the priority of the one that we need, so either we need to the depth one to be first or the breadth to be first. So I think if you wanted the J to become first, breadth is the most suitable for this sense, okay, for this application. But if you wanted to be N to be found first in the searching sense, so that would be the choice. Okay, so that would be the strategy in order to find the data or to solve the problems, okay, in AI. Mm, mm. Okay, I think maybe. Okay, so jump to the rule-based system. I think this is very clearly I think straightforward. One of the earliest form of AI based on if-then, so consists of the set, encoded system, and guide decision making. So that would be the common thing. So we have data, we bring the data in, and this engine will be somehow check the rule, and the rule will be respond back to the inference. The inference, if I may say over here, is like this. So we have a system, we have x, t for example, we have y, t for example. So this is ft for example, system. Okay. So the inference engine is this. So the solution is y and the x is t. So the rule is logical inside this. So that would be the same. Okay. So after the data has been checked and either the rules is obeyed or perceived in that sense, so basically decision will be made by the inference engine accordingly to the rule. Okay, let's say a when x is smaller than a, then choose b. When x is larger than a, choose a. For example, okay. So there will be rules behind that. Solution is b or a. So this is the one that happened whereby if we have rules and based system. Okay. So advantages and disadvantages is simple to implement, good, well, but okay. The most important thing of rule based, so that's the thing happened when I mentioned early in the uh, what what page is that? Hold on. Okay, page 4. So now we are page 20. Okay, 4. Okay, imagine that as I start the lecture just now, I use from here, a rule base. Okay, so there must be something meaning, right? So then goes here. This one is rule base, does not adapt or learn new data. So remember that I mentioned earlier about where was it? Okay, new data happen here kan? Perasan tak tadi? Siapa yang dengar lah? Siapa yang tak dengar tu, dengarkan balik dalam video coming soon. Okay. So this one is new data, guys. This one is old data. Okay. Old data in rule-based system was fine. So that would be easy, good for the well. Okay. But the thing is, when the moment that we inject or insert or bring a new data to that particular model or system, so there will be a shaking. Okay. Difficult to scale and maintain with increased complexity. Okay. What is increased complexity means? Example, let's say the feature, for instance. If we talk about one or two feature, might be easy. So let's say we enlarge the feature four. Contoh, now we put one lah, easy. So say that this one is dog or cat, right? When we enlarge the things related to that particular data, feature means mm, length of ears for both cat and dog. Or we can say that what is the characteristics? Or okay, tail and color of cats and dogs. So some people might heard about two colors cat, meaning male or female. Ada tak yang tengok kata-kata tu? Kalau kucing tu dua color, dia lelaki ke perempuan? Jantan betina. So things like that. And the others. So when we talk about cat and dog, might be easy for that sense, but we enlarge or increase in the complexity of the data, so that would be difficult to rule based. Okay. Okay. Now, after we did cover all the thing based on that, we did tree searching, we did describe and match, we did rule and base, and we did constraint satisfaction technique, right? Just now. I think this one we did. This one, I guess. So we did discuss everything. And now we wanted to go to this one, reasoning. Okay, 21. Okay, so reasoning means the idea of stating something or give a conclusion based on the previous given data. So that is the idea by Greek scientists or scholars, Plato, whatnot, the list of Greek scientists. So example, A is B, B is C. A is B and B is C is basically statement has been given to that particular model. Okay, so when A is B, B is C is given, the model in deductive reasoning will say A is C. So that is happening in a reasoning time of period in order to criticize the science and logic. Okay, so in artificial intelligence, so reasoning is considered as the early age of a technique. So we have inductive reasoning and we have deductive reasoning. We have two. So both reasoning form have a premises and conclusion. Premises in Malay we call it kenyataan, fakta. Conclusion adalah inference or we call it kesimpulan. Okay. So based on the premises given, A is B, B is C, the conclusion is A is C. So that is kenyataan, and then we can conclude based on what are given to us. Okay. So premises is true or false, a statement that helps from the body of the argument, which logically leads to the true or false conclusion. Okay. So we will talk about that for a second. Okay, so in order to compare them in the perspective of a wide range, so definition for the what color is this? Okay, the deductive is a form of valid reasoning, while this one is inductive is the general. Okay, so that is different between two things. Okay, facts and general. So approaches for deductive is top down, so top to down, while the inductive is bottom up. Okay, so deductive reasoning starts from premises, while inductive starts from the conclusions. Okay, so that is the idea of two different world or environment of that particular reasoning. Okay, then validity is very good to digest over here. Hold on. I'll try to change to the red color. Can you see that? Okay. Inductive, the conclusion must be true if the premise is true. So this one, the conclusion of that reasoning must be true if the premise is true, meaning the forcing the a conclusion to be true if we have the premises true. So maksudnya, if the premises is true, the conclusion might not be false, cannot be false. So that is the limitation of deductive. So while yes, when inductive, fast and easy, as we need evidence, if we add the facts, so then there will be conclusion. So that is what we call it generalization. Okay. So that is generalization of that sense. Okay. So normally a theory, hypothesis, pattern, and confirmation in as a process inductive, while the inductive have observation, pattern, hypothesis, and theorem. Okay. So yeah. Okay, this is idea of top down. So basically A is B, C is A, while B is C. So we can say that the moment that we have A is similar, so we can jump to conclusion as B is C. So similar as when A is B, B is D. So then this is will be the argument. So now A is D, right? So similar as that. So that is the idea of deductive. So here specific and this general. So in deductive sense. Okay. So example, so this is general, this is general, this is spec. This is general, this is general, this is spec. For example, all students eat roti canai, majority of the student. So Ahmad is a student at FTKEK, but the specific conclusion jumps, therefore Ahmad eats roti canai. It's very specific, right? So Ali is a student of FTKEK, so therefore Ali eats roti canai too. Okay, so adakah semua makan roti canai? Some of us doesn't eat the roti canai, right? So then, because of the premises is true, so this must be true. So that is the validity just now we mentioned earlier here. Okay, all the athlete work out in the university gym. Ikmal is an athlete, one of the athlete. Therefore, Ikmal works at our gym. So, but the thing is, not all of the athlete work at the gym. Sometimes they work out at the stadium, work out at the botanical, and so on and so forth. So that is the limitation of what we gain in here, right? Ini. So that is deductive. So deductive means a type of logic which one goes from the general statement to the specific. Okay. So all human are mortal. So this is the example. Zidane is a man. So therefore Zidane is a mortal. So are this particular thing true? So not necessarily true because a mortal is different kind of things, right? Okay. So inductive reasoning. So we have bottom up. So broad to linear. So okay, my neighbors, for example, my neighbor's cat hisses at me daily. Ni cat hisses at me daily. And then on the other scenario, so later at the pet shop when I went there, all the cats hiss at me. Okay. All right. So this one is specific. This one is specific, right? Observation. So now, therefore, all cats probably hate me. Okay, meaning, to jump to make a conclusion of inductive. So basically, the one conclusion has to be made is having probably, generally or whatnot. So because they become generalization, the generalized statements that has been brought from the premises and above. Okay, one premises, second premises, which are very specific. Right? Okay. Right. So this is the example. Every quizzes has been difficult. So therefore the test would be difficult. So this is the very broad. This is a specific and this is broad. The teacher uses Microsoft Excel in last few classes. Therefore, all the teacher will use Microsoft Excel tomorrow. So that is the thing. Become generalization. Okay, so what are the things in inductive reasoning is the moment that we call it pattern. Pattern is the thing that has been digested by machine based on the repetitive or pattern, okay, occasion that has been observed by the computer vision. So, example, 3 to 6, 6 to 9, and 9 to 12. So, basically, the next number is plus 3 means 15. So, that is the patterning. So, see what might happening. So, should the next number will be 16, guys? Shouldn't. So because of the uh, pattern behavior of that particular sense between the previous data, 3, 6, 9, 12, 15, 18, etc., etc. So that will be pattern observation by this. So we can call here as generalizing the data because of the previous data. Right. Deduction versus induction reasoning. Okay. This thing happened I just mentioned as example. It's not true. Happened in last semester's final exam. For Berg 4333. So this and this and this. Okay. So normally, what had happened, the things are happen from the pattern itself is depending on inductive. But depend on the facts or rules are related to deductive reasoning. So that is the things that you might be considered with. So logic. Okay, now we go to the next one. How many slide do we have? Hold on. Okay, tak banyak dah. Okay. Example deductive learning. Pepe follows Chinese diet. Pepe. Sorry. Okay, the most important thing is here. Adding premises does not change. In deductive, adding in inductive, adding makes stronger and weaker. So that is might be we need to consider about. Okay. So in deductive, whatever it is, whatever statement that has been added to the premises is not much, does not change the validity of argument. Okay. So that would be the idea. So means inductive might be good, but we can't say that deductive is not good. Okay. It depends on the situation. So this is scenario number 1. Inductive. Cows are blocking the traffic. Lions are blocking the traffic. Cows and lion are animal with no rationale. So now, this is cow blocking, right? This is lion blocking. Cows and animal are animal with no rationale. So hence, all the creature that walks in a group and blocking the traffic are animals. Number 2, design a system to filter COVID-19 suspect patients. So high temperature, my Sejahtera data, and pink blood bracelet. So we have this as a parameter. So this is the inductive one. So say that the first data, high temperature, yes. Close contact, diagnosed with COVID, yes. Second data, high temperature, then etc. So therefore, input data, with input data high temperature, and yes, contact close, then COVID-19. So that is the inductive behavior of reasoning in the real life. So yani is kind of a good example, but it's just a remembrance for us. Okay. So in the eyes of AI, it's not in the eyes of human. So basically, when we see this guy, we know about he's a cycler, and obviously not animal. But the thing is, based on the AI, what AI should understand to perceive the image, right? So that would be something to be digest. Okay. So speaking of okay, this is procedure code. I think most of us know about procedure code. So anyone doesn't know about procedure code before? Anyone? Hopefully tahu lah. So procedure code is basically the simplified version of a long or full code. Okay, so that is definition of the thing. So normally, mm, uh, I will show you the. Hold on. I'll show you exactly in my paper. Saya tak tunjuk paper orang lain lah. Saya tunjuk my paper. Hold on. I'll open up. Hmm, where is it? Simultaneous. Okay. Can you see? Okay, stop sharing. We go to the next window. This. Okay, can you see the slide right now? I think you can. Okay. So this is my paper during my time doing PhD 2019. So if I not mistaken over here, so this one is procedure code, what I meant. The simplification of the whole lot of how to say, the full code, which has been portrayed in a written manuscript, especially journal, proceeding, conference paper, and whatnot. So this is the way that we tell the world. We don't give a full coding, our coding to people, so that people can know everything about the code, and without coding, the people can use the codes. But the thing is, if we are giving the procedure code over here, so people are having kind of idea of what we are doing in this particular paper, right? So imagine that this is a simultaneous image matching via stable marriage algorithm for person aggregation. So input are given in to the Python script. So in procedure code, we don't mention about what kind of language code that we use. Okay, whatever it is just a flow. So for example, for 1 to n, etc., and this is this and this, okay, to the end. So that is the idea of comparing the procedure code and not a procedure code right here. Okay, all right. So okay, so this is deductive. Deductive is straightforward without any broad general conclusion that we have. Okay, so that is deductive so far. So this one is write a procedure code using deductive or inductive to decide the horn, or not when the road is blocked. We end our session here. So I think the next class will be the Thursday. Thank you so much. I'll see you on the next class on Thursday. Assalamualaikum and selamat buka puasa. Bye.